Good afternoon, everyone. It is approximately 1 o'clock, and we are going to go ahead and get started with our program this afternoon, a NASA GIS Remote Sensing Virtual Connection. I'd like to welcome everyone. My name is Dr. Ann Weiss. I am one of the educator specialists here at NASA Langley Research Center. And so I'm going to talk for just a couple minutes, and then I'm going to turn it over to my co-host, Dr. Wendy Stout. Let me actually share my screens and share with you a few ground rules that are going to guide us today. And if you would please. Okay. First, make sure that your microphone is muted throughout the process of this afternoon. That'll make it much easier for everyone to hear the speaker who is currently up. Secondly, if you have any questions, we're going to ask that you save them for the end. We've got a really exciting lineup of NASA, GIS, and remote sensing experts lined up for you this afternoon. And we'd like to give each one of them equal opportunity to talk about what it is that they do in their line of work. So I'm going to ask that you hold off your questions. On the screen there, you should be able to see a web link where it says submit your questions to. This is a rather unique question tool. It allows you to submit your questions, but then it also allows you to see other submitted questions, and you can upvote those that you'd like to hear a response from. So as we go through each of this afternoon's presentations, if you have questions, please go to this website and we'll routinely post it in the chat box again. I have two co-hosts with me, Richard Carney and Dr. Keith Duclos, who will be ably helping me man the chat box. And basically what we'll do is we'll repost that web link throughout the first hour and a half so that you can post your questions and upload them, and then I will draw them from during the Q&A session. So that way, by doing that, we hopefully will keep the chat box open for any technical issues. And then the last thing that I'm going to mention before I turn it over to Wendy is we do have a number of webinars coming up, two that you might be interested in. One will be April 9th, the other will be April 22nd. It'll be the same material, and it'll talk about an instrument that's up on the ISS that incorporates GIS and remote sensing technology. So if you are interested, I will try to post this again at the end. These two programs, unlike today, do require online registration, so there's web links there. So we'll make sure to put that information either back up on the screen at the end of the program or in the chat box if you might be interested in attending those webinars. So what I'm going to do now is I'm going to get out of my screen share, and I'm now going to go ahead and turn it over to Dr. Stout. And Dr. Stout, the floor is yours.
Thank you so much.
So let me get your slides up here.
All right. Thank you, Ann, and hello, everyone. Welcome to today's webinar. My name is Wendy Stout. I'm the Director of Spatial Analysis and GIS Professor at the University of Richmond. And let's see. When Ann and I started planning this webinar back before Christmas, coronavirus wasn't on anybody's radar. We had no idea that our idea would turn out to be so timely and relevant. Many educators and students all over the nation, like the University of Richmond, have now transitioned to online instruction. In this time of uncertainty in our rapidly changing world, the field of GIS and remote sensing helps scientists address our biggest challenges. I noticed Dr. Joseph Karski from Esri was on the call, and Esri has termed GIS with the phrase, the science of where. I think that's very appropriate. All of us as individuals, students, professors, and even the broader society are impacted by things such as the scarcity of testing kits, ventilators, food, even toilet paper scarcity and shortages at this point. Not to mention larger issues that our society has to address, such as climate change, natural disasters, and air pollution. All of those things are very important, and our human footprint creates many challenges that NASA scientists are looking at to address now. Next. So we're going to take a look at the agenda in just a moment, and our presenters today will share what the work that NASA GIS and remote sensing professionals and how they're creating information that is directly changing how we see, understand, and interact with our world. Next. This is showing a NASA Landsat 7 satellite image back from 2000 of the Lena Delta. It is a stunning preview of the exciting remote sensing work that NASA does, and you'll hear more about the work that NASA is doing in this area from our presenters. Next. Okay. Here I'd like to share an overview of today's agenda. Our NASA subject matter experts will be sharing their expertise in GIS and remote sensing with us today. I'd also like to take this time to thank the NASA Langley STEM engagement team for all their hard work, and especially our moderator, Ann Wise. A recording of today's event will be made available. And if you're just now joining us, welcome. My contact information is on the next slide, and I'll now turn it back over to Ann to introduce our speakers. Thank you.
Thank you, Dr. Stout. Let's see, our first presenter is going to be Chris Resnick, and hopefully I pronounced your name correctly, Chris. So I'm going to go ahead and get your slides here in just a second. So if you give me a moment, reminder to everyone, please make sure that your mics are muted, and that way then that'll help our presenter. All right, so let me get your slides up, Chris. Okay, Chris, floor is yours.
Thank you so much, Anne. And thank you as well to Wendy. Thank you guys for organizing this. I know that the circumstances aren't the most ideal, but here we are. And I have a little bit of an atypical remote sensing case for you guys today. As the presenters said, my name is Chris Rusnak. I'm a measurement technology specialist working at NASA Langley Research Center, along with a bunch of wonderful guys and gals who help me synthesize my data into geospatial deliverables. Next slide, please. So before we get into what specifically I do, I just want to scaffold some of the knowledge so that people understand exactly like what we're getting into here. So my professor likes to call it walking around knowledge. So remote sensing, the best definition I could ever come up with is the non-contact observation of subjects. So really what we're doing is we're just expanding our perception of what we can see and how we can see it. And I happen to use a technology called terrestrial LiDAR. And that technology is Earth-centered light detection and ranging. So my unit sends out a very specific light signature and receives that signature back. And in so doing, you can determine distances very accurately. But really, the magic of terrestrial LiDAR doesn't really come into full focus without co-registration. And that's the assembly of multiple observations together into one product, one point cloud, one deliverable. So remember, for everybody out there in the audience, you do a little bit of remote sensing every single day when you use your cameras, when you use different kinds of devices that capture reality in either the red, blue, green spectrum, like a standard camera, or a fancier unit, like what I use for work. And really, just to reiterate, remote sensors expand the boundaries of what we can see through time, through space, through different types of observations. So these are the two basic types of remote sensing equipment that we use to sense our reality around us. So the quick one is the Faro S70, which is to the left. And the survey grade instrument is to the right. So the main difference between these, just to not get lost in too many details, is that the one to the right helps us ground the work that we derive from the one on the left in real geographic space. So whenever we justify, okay, we've scanned a room, but where is the room? The one on the right can tell you within a centimeter of itself really where that room is on the face of the earth due to the process of setting it up through a traditional survey workflow. The one on the left will just tell you where that room is relative to the rest of the data. And that'll be important as we continue on through here. And the center graphic is just a wonderful little piece I found online through ResearchGate, where it explains sort of how the scanners collect their information. So as you can see, there are mirrors or little hoods that protect the lenses, and the light emits through those mirrors and is received back through the same hole in the range of motion as seen in the graphic. And that allows you to develop something called point cloud. And I'll actually show you a couple of screen caps of some point cloud data later, and I'll also work you through a workflow of some data that we've done in a novel case. Next slide. So why do we scan? Why do we have all of this capability? We maintain the geospatial data about the center and its capabilities. It's extremely important that NASA knows what it has, knows what it can do, and when we're asked if we are able to do a mission, we can affirmatively say absolutely and get on it. Because NASA is a main part of government research and development, we want to make sure that we can take on all of the cutting edge research that today's day and age requires to keep up with our technological advantages. Next. So what do we scan? We scan critical infrastructure, whole facilities, testing equipment, and the odd request. So just to walk you through some of what you're actually seeing here, starting from the right, this is the inside of I believe it's a Mach 3 wind tunnel. So this is used for testing small articles that are scale precision design models of actual airframes. So you can determine a lot of things from physical testing that you couldn't otherwise with physics engines. And in the center, you actually see a sample of point cloud data. That happens to be in the middle of one of our largest testing facilities on center, the same one that we mentioned, that we captured in the map on the previous slide. And the last one we're going to spend a good bit of time with. It's the funky one where I definitely hung a $25,000 sensor upside down for science. So next slide, please. All right, so the odd request. We at NASA tend to find everything as a bit of a challenge. So whenever we're given a bit of an odd case, I personally find satisfaction in finding a way to address a need that we didn't previously understand or even think would be a need. So in this case, a project manager for flight hardware development mission came to us with an odd request. And to paraphrase, like, can you scan this very expensive piece of metal because we want to mount a flight article on it and save the taxpayer like $80,000? And I'm like, sure, why not? So the image to the right is actually his notes direct from the request. So what he's looking for is in the red circles. I don't know if you guys can see particularly well on the slide, but the red circles sort of at 12, like 1 o'clock, 6 o'clock, and about 9:30 to 10 o'clock. Around those circles, he's really looking for places where he can drill extra holes to mount this piece of hardware. So I was like, okay, yeah, I haven't really used my sensor that close yet, but we'll give it a shot. Next slide. So I get to Goddard Space Flight Center, and this is the left image is the first image that I'm able to take with the scanner. This is the direct extract from the color render taken by the camera in the head unit. And then the right, well, that's the shenanigans we get into trying to solve a problem. So you'll actually notice that I've marked the 0 coordinate in the previous photo with a little badge case there on the floor. And the civil servant and I actually opened our pockets for science. Those are both of our wallets propping up the tripod to make sure it was level when we took the data. Next, please. Okay, so this is the workflow. Now we've gone from reality to virtual reality. This is a view from the same scanner setup of all of the data taken on the vibration plate. So in the center, you see the center spherical targets. the wallets even show up, and we're able to start seeing what look like potentially holes. Next slide. So after that, I've gone ahead and I've edited out all of the data and cut it away to the point where you can see down where each dimple, each dark dimple in the photorealistic render shows where the hole would probably be. So this is what we would probably call a clean surface. And we would send this off to computer-aided design modeler. Next. And then this is what I was actually experimenting with recently. It's called creating a mesh solid. So this is the raw output of creating little triangles in between every one of those millions and millions of points to make it into a solid piece of geometry. And still inside of here, you can see where some of the divots are as to where those screw holes are. The job spec was actually for 1/8 of an inch radius around each screw hole. We'll get to that here in the next couple of bits. The next slide should have a punch-in of the southern section of that particular vibration plate. So in here, you actually can see even clearer the little bitty pieces of mesh that stand out in contrast to the really high density points. It look almost like flats versus like fuzz. And then for the last slide, this is where I've actually cut away the machined surface, and you actually end up with the data overspray and the geometry created from that data overspray that's sitting inside of the holes. Both of these last two measurements are what are going to be used for creating the physical measurements and determining whether the unit is actually in suitability or not. Yeah, this is just like this is a quick little look into some of the work I do on a regular basis. And if anybody has any questions, I would be happy to answer them about the equipment, about more of GIS's mission. I know this is a bit more of an atypical case. I was actually going to do a live data stream to try to show you a building in manipulated form, but I actually tried it with Anne, and I believe I crashed our call. So this is the best I could come up with in the circumstances. But one last slide, please. And it's definitely a team effort. I have a particular set of skills, not to quote Liam Neeson, but a lot of other people on my team do a lot of excellent work, but specific shout outs go to Jason and Jason, senior MTS and survey leader, and Jason Baker, assistant surveyor. You guys help me do a lot of my work, and I really appreciate all of the team's contributions to what I'm able to do. Thank you guys.
Thank you, Chris. And yes, we are very, very sad that you were not able to do the live stream because it was very interesting before the whole system crashed. But maybe that's an excuse to do a follow-up program to this one today.
Hey, I would love that.
All right, let me get out of my screen share here. What I want to do before I turn the reins over to Cindy is I want to put up the screen again that has the information for the questions. As I mentioned at the beginning, because of the time constraints and making sure that everyone has enough time to present their GIS remote sensing work, we're asking that you hold off on questions, even if they're specific questions to a particular presenter, until that Q&A session at 2:30 p.m. Eastern Time. So I've put this slide back up so that you can see, again, that link for the question tool that we're going to use. So if you have any questions specifically for Chris, I highly encourage you to go to that link that's there, submit your questions to, and type in your questions. As I mentioned at the beginning, also just a reminder, you can take a look at other questions that have been submitted and upvote those to make sure that those questions are the ones that get asked during that Q&A session at 2:30 Eastern Time. So at this point, let me get out of this slide, and I will get Cindy's slides up here and let her have the floor.
Great, thank you, Anne.
So give me a second, Cindy,
Yeah,
while I find your slides.
No worries.
Okay, hopefully they're there.
There they are. Okay. Well, I'm really excited to be presenting this information to all of you about our capacity building program. And what I'm going to focus on is really resources available to you for learning remote sensing in different application areas. So my background, I'm a scientist in the Earth Science Division, specifically applied sciences, and I've taught remote sensing for many years and have been involved with the capacity building program. So I'm very passionate about what we do in this program, and hopefully we'll get you excited about it too. Next slide, please. So I always have to start off my talks with this graphic because this is why we do what we do in NASA Earth Sciences. I always start off because a lot of people don't even know that NASA does Earth science. Certainly we have a lot of planetary scientists and space scientists that also do GIS, but I'll be focusing on our Earth science program. And so all of these satellites that you see on here take measurements on the land or in the oceans or in the atmosphere. And then on the left-hand side, you can see that list of instruments that are on the International Space Station. So all of these combined help us study the Earth as a system. Next slide, please. In the Applied Sciences program, we basically take all the great research that's done by the scientists and apply them to real world issues in these 5 areas. So eco-forecasting, disasters, wildfires, health and air quality, water resources, and then I'm going to be talking about the capacity building program because that is the program that develops tools and methodologies for people to learn how to use the technology for all these different application areas. Next slide, please. So within the capacity building program, we have 3.5 kind of elements. And I'll tell you a little bit about each of these and how each of these elements have tools that can help you learn about remote sensing and GIS. Severe, ARSET, develop, and then a program that's near and dear to my heart is this Indigenous Peoples initiative. Next slide, please. So Severe is our international capacity building program. It's a collaborative program between NASA and USAID, and they develop nodes in other countries, and primarily in developing countries, to focus on specific issues in those countries, so different kinds of application areas. But they also build the capacity of those countries to use Earth observations for a variety of uses. Next slide, please. And the thing that I wanted to point out to you that will be hopefully really helpful for you, especially for those of you that have a little bit of remote sensing background, is this SAR handbook. So SAR is synthetic aperture radar, and it's a challenging technology to use. And so Severe has developed this really wonderful handbook where you can learn how to use SAR, and this is specifically for forest monitoring, but it also gives you great overviews and examples and hands-on exercises on how you can learn how to process radar data yourself. And the link is there on the bottom. It also has some FAQs if you have specific questions about how to use radar data. So I highly recommend that you download this handbook if you're interested in learning more about radar data. And of course, everything that I'm telling you on this presentation is all available free. Next slide, please. So Develop is our internship program, and it works with end users. So it works on real world problems in collaboration with end users, such as resource management agencies and other kinds of organizations that can use Earth observations to address different kinds of issues. So for you students out there that are 18 or older, you are eligible to apply for this program, develop. Next slide, please. And these are the deadlines for that internship program. The deadline for the summer term is already passed, but the deadline for the fall term will open up in May. And then there will be a spring 2021 term as well that will open up in August. And on the right is the image of where all the developed nodes are located. So when you do a developed internship program, you will actually get to choose which node you'd like to work at. And I didn't tell you at the beginning, but I'm actually out in California at Ames Research Center. So we have a really awesome node at our center. So I highly encourage all of you to apply for this internship program. Next slide, please. Then this program, the ARSET program, which is Applied Remote Sensing Training Program, will be very valuable to a lot of you. So this program provides webinars and trainings on the use of remote sensing for all of these 4 different areas that you see here: air quality, disasters, eco, and water resources. And again, all of these webinars are recorded and they're also freely available. Next slide, please. And the really great thing is that they're available at all these different levels. So if you know nothing at all about remote sensing, we have some really great fundamentals webinars. And then as you gain more knowledge, or if you already have knowledge in the use of remote sensing and or GIS, then we have these more advanced levels that are available to you that include hands-on exercises. Some have homeworks and things like that. And they use both commercial and sometimes freely available open source software as well. So I highly recommend that you take a look at these webinars in all these different areas. And if you have any specific questions, you can ask me at the end of this presentation. Next slide, please. Lastly, I just want to give you a little information about this work that I'm doing with Indigenous people. So it's providing remote sensing training to tribes, primarily in the US, although we're starting to go more outside the US, and really focusing on the use of Indigenous knowledge within our trainings, and focusing on issues that are important to the tribes. And so this is really a different way for us to do remote sensing training, and it's been incredibly rewarding, and I'm learning personally a lot from working with tribal communities in the US. Next slide, please. And these are just a list of the workshops that we've done with tribes. And all of these materials, by the way, are available, again, freely available to anyone that's interested. We don't have them online yet, but if you send me an email, I'm happy to send you this information. Okay, next slide, please. And that's all I have. So I look forward to answering any questions that you have at the end of this webinar. Thank you.
Okay. Thank you, Cindy. I'm going to leave this last slide up for just about a minute so that if anybody wants to make note of her email address, you have the opportunity to do so. So let me just give a second there. And as with Chris, if you have any questions specific for Cindy, please go ahead and put those into the question tool. Give it just a couple more seconds. I'll bring up that slide again so you can get that address. Okay, thank you, Cindy. So let me now get out of these slides, and let me then get into my slide again. Screen share. Okay, where is it? Okay, so there again is the web address for the question tool. Submit your questions to the link there. Okay, all right. All right. All right, so let me now bring up Rusty's slides and allow her now to go ahead and have the floor. So give me a second, Rusty. Okay, Rusty, the floor is yours.
Great. Thank you, Anne. I think that one thing that is coming very clear through, and will come clear as we finish this series today, is how NASA provides an incredible distributed ecosystem that is supporting remote sensing and GIS, and it's available for all. I work with the Globe Observer program, which is the citizen science program that supports the observations of Earth from space by engaging citizen scientists and making ground-based observations that can accompany that and be used for analysis. But I just wanted to say, you know, Cindy just gave a really great talk. She mentioned Surveyor. Globe Observer is using the Collect Earth platform, which is a NASA and USAID project for doing some of our land cover analysis. The Globe Observer also, I was involved in supporting a develop team last year, working with mosquito data. And we're also working closely with some programs such as Earth to Sky, working closely with Indigenous college students who are collecting mosquito data. So I just wanted to say, even though we're each doing different things, we're very much connected. And so I hope you'll be reaching out to us and we can really help you find the best support you need for the questions that you have. Okay, so if you want to go here and take a look, you'll see that we developed Globe Observer as a way to collect on-the-ground data. As a shout out to Esri, we actually used Survey 123 to create the beta model for the Globe Observer Mosquito Habitat Mapper. So if you have used Survey 123 as a platform for data collection, you'll be really familiar, I think, with this tool. It just provides the ability to collect different kinds of categories of data. Our tool has, our app has 4 tools: the cloud tool, mosquitoes, land cover, and trees. I'm just going to go through these super quickly. Next slide, Anne. You'll see here that at each one of these tools geolocates you, provides a date and a time stamp. It provides a map and a lat long. You can also input these values manually, or you can use a handheld GPS receiver, or you can use the GPS receiver that's in your phone. But this is an Earth system, so all these tools work together, and we encourage people to take all these measurements because we are providing that Earth system contextualization for all of these observations. Okay, next, please. So one of the tools is the cloud one. By photographing clouds, you are getting a new perspective on the atmosphere that we don't see from satellites. It's from the ground up. And this is really important because it helps us to refine the algorithms that we use to understand what the spectral signatures are that we're getting from our satellites. Next one, please. The next one, which I'm actually the science lead for the Mosquito Habitat Mapper. I'm originally a climate scientist. I was at the University of Nebraska, and previously to that, I was at the University Corporation for Atmospheric Research, which is a NSF-funded climate facility. I was interested in mosquitoes because we are watching the movement of invasive species in response to a warming world. And this is a way that we can get those observations from people in the Northern Hemisphere and in the Southern Hemisphere as our mosquitoes are moving from the equator towards the poles. It also is really become quite important, though, for public health, because we are beginning to identify patterns about where we're finding those vectors of disease, and we are able to ground truth it essentially with these observations. And the next one just shows the land cover app. I'm also on the land cover team. This is a tool that just enables you to take pictures, and it's so easy. You make an observation up, down, north, south, east, and west. That's the minimal thing you can do. After doing a short tutorial, you're also asked, if you wish, to describe the land cover so that data can be then utilized in essentially assisting in the observation, in interpreting the satellite observations. The last tool, which is the tree tool, which is the next slide, we're looking here at tree height and tree diameter. This is really important data. It also supports some of the data that's been that has been collected now by ISAT-2 or the JEDI instrument, and all these tools then can work together. You know, when we look at where mosquitoes are, one of the variables is what are the height of the trees? We're finding that a certain height of tree is correlated well with where we're finding vectors of disease. So it's really amazing how these things are interrelated. Okay, the next slide just shows you the kind of data that you have available to analyze and utilize in a GIS class or for a project. What's really exciting about these data sets is that they are unique, they are not overanalyzed, and so it provides you an opportunity to do real, original, and potentially publishable research. All the data that we have, if you're in a GIS class, you probably understand CSV files or KMZ files. These are our data automatically can be downloaded for use in mapping programs using these different file formats. So this shows you right now, today we have about 20,000 mosquito habitat mapper observations from around the world. In the next slide, you'll see that we also have lots and lots of about 30,000 land cover and tree height data observations. And the same thing holds true here. So we do have some tools that you can use that will enable you to bring in these data sets and then conduct your own analyses using your favorite GIS program. In the next slide, I just wanted to show you that the Globe Observer data can be analyzed in conjunction with environmental data that is obtained by satellites. You can access this data through the WorldView, EODIS WorldView satellite portal. It might be even easier at the outset if you use the data that has already been ported, that is already served up, for instance, by a provider like ArcGIS. They have the World Atlas that you can use for looking for data. So there's lots of ways to bring in the satellite data, look at it in conjunction with the Globe Observer data, and do robust analyses. Next one, please. Okay, so when you get the data, what is next? Well, we have a bunch of resources that are available for you starting at the very beginning that can get you engaged in looking at the data, analyzing the data. And one of the things that we do have is we have a data discovery tool. It's called the Globe Visualization Tool. I'll show you the URL, I think, in the next slide. But this will allow you to look and just look at the kind of patterns. You can say, wow, there is a lot of data in Thailand. That might be a very interesting place for me to look and to see if I can see some patterns exhibited between the different parameters that we find in ecological data or environmental data. In the map, we call it the Globe Viz map interface, you can click on any one of those dots and you can see that it'll tile in right down to a community. So you can do data analysis at different scales, which is very important. And it also will provide you with, if you use something like ArcGIS, you're familiar with a map box. Here we have map boxes that show you some photographs and some descriptions of the data that's available from that point. So this is a very rich data set. We also have, though, a bunch of different resources that we have been developing over the past year. We've been doing webinars. Globe Observer has a campaign which is called Globe Mission Mosquito. And we have had a lot of really preeminent scientists who have come and talked to our audience of primarily high school and college students, but also teachers and even some middle school students. We have, besides our webinar series, we also have a blog, And here are just 3 different blogs that might be interesting for you if you're thinking about using some of the Globe Observer data in an analysis using your map tools. And these can be accessed at this URL. In the next slide, I will show you that we also have a series of webinar tutorials about what to do with data, what happens to your data, that talks about Globe Observer data in general. We have some scientists that actually use NASA Earth observations, and they will provide introduction how to access some of these NASA data sets specifically for vector research. But there are also many different kinds of resources that you can you can see here that are archived webinars. And if there's something that you can't find, I'm going to ask you to please come to my office hours and look for those things. Okay, the next slide, please. So I just wanted to say that right now, like so many people, I'm working from home. That gives me a lot of flexibility. So I'd like to let you know that my office hours are open for all of you. And I really hope to hear from you and give me a question. And like I said, I'm working within a very rich and distributed ecosystem. And if the question isn't the right question for me, I will contact one of the other presenters or other people that I know. So here are some of the URLs for some of the things that I have talked about today. And I just want to thank you so much for coming to this webinar. And I am so excited to have so many people that are interested in remote sensing and using GIS tools. Thanks very much. Look forward to hearing from you.
Okay. Thanks, Rusty. I'm actually going to leave this slide up for just a moment so that you can write down Rusty's email address if you don't already have it. We'll make sure maybe to have our presenters, if they would like to put their email address in the chat box so our attendees today can reach out to you if they would like to follow up with any of the resources that you have presented today. All right, so let me get out of Rusty's slides here. Okay, and come back into, I think my co-hosts have been, yes, my co-hosts have been putting the web link for the question tool up there. So if you have any questions specific to Rusty, please make sure that you go to that web address, arccnf.io, and enter those in there and upvote on any questions that you see that you would really like to have answered. And so at this point now, I am going to pull up Desiree's slides and let her have the floor. So Desiree, if you'd give me just a moment, I will find your slides and put them up there. All right, Desiree, the floor is yours.
All right, thank you so much, Anne. So my name is Desiree Wilson, and I am an Associate Scientific Programmer at NASA Langley Research Center. And I'm going to be talking about what I do with GIS and remote sensing. Next slide. So to give you a little bit of background about myself, I just recently graduated from South Dakota School of Mines and Technology in May of 2019. And while I was there, I majored in geology, but I minored in geospatial technology and remote sensing. And I really liked it, and so that's what I decided to follow for my career path. So I had several GIS internships with my state government, South Dakota Game Fish and Parks Division. But then when I was a senior, I had the opportunity to come work with NASA through their NIFS internship program. And there I was a data visualization and science education intern. And then after I graduated in 2019, I was actually hired on to work with GIS at NASA Langley. Next slide. So what are some of the ways in which NASA uses GIS? So one of those ways is that they use remote sensing is to study Earth system science. So NASA's Earth satellite missions collect data on the Earth, which can be used to better understand some of these different Earth system interactions shown in this diagram. So very much an emphasis on atmospheric science, carbon cycle and ecosystems, climate, and weather. Next slide. So, oh, I guess my picture, oh, there it went. So I'm just going to talk about my first experience working with NASA, which was my NIFS internship with the My NASA Data program, who I still work for half-time today. So My NASA Data started in 2004 as a project to make NASA Earth data more accessible and is dedicated to helping teachers of grades 3 through 12 teach Earth system science using data from NASA Earth satellite missions. My NASA Data has a wide variety of educational offerings aimed at improving data literacy among students. Next slide. And so on this slide, I've listed some of the different educational offerings from My NASA Data, and I've highlighted there in yellow the areas in which I work in. And so these areas are creating instructional resources and providing data access and visualization. So I mainly work to create lesson content that includes NASA GIS data. And so this could include creating animations, visuals, or story maps. Next slide. So I wanted to mention one of the big features about My NASA Data, and that is our visualization tool called the Earth System Data Explorer. So this visualization tool allows teachers and students to easily visualize and compare NASA Earth science data in one place, and it includes plain language descriptions of these data sets. So as a side note, the raster data from the Earth System Data Explorer can be downloaded in NetCDF format and is very easily imported into ArcGIS and QGIS software. So if you're ever looking for scientific data to work with in your projects, this is one resource that I think could be very helpful for people of all ages who are interested in NASA's satellite data. Next slide. And then real quickly, these are just some of the different data collections that we maintain for the Earth System Data Explorer. So many of our most popular data sets include temperatures, net radiation, precipitation, soil moisture, sea ice extent, and sea surface temperature. As you can see, we've got categories for all of the different spheres of the Earth system. Next slide. So working with My NASA Data, probably my main focus has been working with story maps. And if you're not familiar with story maps, they're really just a neat way to combine your map GIS data with other multimedia content, such as images and videos, along with this narrative text. And at My NASA Data, what we do is we pick different Earth system phenomena, and then we create basically a lesson plan for students centered around the different NASA data that can be used to explain and analyze these topics. And so far, we've created story maps for all of these different topics: the hurricanes, urban heat islands, sea ice extent, volcanic eruptions, and phytoplankton, with an ocean circulation story map coming soon. Next slide. And here's just a slide showing the hurricanes as heat engines story map with the URL for the lesson plan located in the top left. So I encourage you to check this out because these are a great resource for spreading information and allowing users to interact with data without having to download and access it themselves. If you're interested, you can find all of our story maps that we've created on the My NASA Data website by searching for story maps in the search bar. Next slide. So I put this slide in here just to mention how important I feel GIS is to science education and data literacy. It's said that most people are visual learners. I consider myself to be a visual learner. And so I just feel that this makes GIS an extremely powerful tool for understanding relationships in science. And in my own educational path, I found that I wished I had been exposed to more data visualization early on, as it probably would have helped me to have a more solid foundation in earth science in my very young years. So on the slide, what you see here is an image of cloud fraction and an image of surface, the flow of energy into a surface by shortwave radiation. And you can start to see the patterns right away in the areas with high cloud cover. Less shortwave radiation is at the surface. And so I'm showing you this just because I feel that it's one thing to be told about a relationship between two scientific variables, but it's very much a completely different thing to see it. And I think that resonates with a lot of people. So I feel that GIS, it's a tool that can really all help us improve our understanding of a lot of different scientific concepts. Next slide. And then, so I talked with you about my work with MyNASA data, but I actually also work for another group at NASA Langley Research Center, and that is the Atmospheric Science Data Center. And my work with them is actually very similar to my work with MyNASA data. So at the Atmospheric Science Data Center, it's one of the 12 distributed active archive centers for NASA. And what this means is that these centers are responsible for the archival and distribution of all of NASA's Earth science data. So each one of these centers has a certain data specialization, and the Atmospheric Science Data Center, as you would expect, distributes much of NASA's atmospheric data. Next slide. So on this slide, I've listed the Atmospheric Science Data Center's data disciplines, which are aerosols, clouds, the radiation budget, and tropospheric composition. With the URL there, if you're interested in accessing any of these data, you can find them there at our website. Next slide. And then, so as I mentioned earlier, my job for the Atmospheric Science Data Center is very similar to my job at MyNASA Data, in that I really work to make data more accessible to the public. So there's been a recent push to make data more discoverable and get it into the hands of those who can benefit from it. And that includes college students and decision makers. You know, not everyone knows how to run a script to access data. So if we can empower users to access this data themselves, we can start to see more people benefit from it. And so how I do this is we work to create data recipes in the form of, say, Jupyter notebooks or instructional guides. We also create story maps and articles that you can use to familiarize yourself with the data in the context of recent events, and then provide resources to help you access the data that we show you in these story maps or articles. Next slide. I thought I would include just a couple slides here on some additional NASA GIS resources. I do not work to create these resources, but I found them very helpful starting out here in my career working with data. So one of those is data pathfinders. And what these are, they're like instructional guides categorized into different topics like wildfires, health and air quality. And what they do is they describe, you know, the different ways data can be used to observe these different categories, and then what tools from NASA you can use to visualize and access them. Next slide. And then one last one, I included what is called the Global Imagery Browse Services, or GIBS. And this is also a resource that you can use to plug in a lot of data into your ArcGIS software, Google Earth. So this website contains instructions for how to get any data set that you can find off NASA Worldview and visualize it yourself with your own software in these 5 different software types. All right, next slide. And that is all I have for you. I thank you so much for having me on this webinar, and I hope that some of these resources can serve you well. And please let me know if you have any questions for me.
Thank you, Desiree. I'm going to take a moment and allow folks to write down your email address if they would like to grab that, or or if you could put that in the chat box, and you can have it there as well. Give it a second before I switch out the slides. Now that does complete our set of panelists in terms of subject matter experts. What we'd like to do now is we're going to switch gears a little bit. Desiree mentioned this briefly, that she had been an intern here at NASA, and so what we're going to do is we're going to give some information about the NASA internships and fellowships program. We're having a little bit of difficulty with the coordinator. She was on, and now Zoom has bumped her off, so we're trying to get her back in so she can do that presentation. So if you give us a moment, I'm going to switch out of the slides here and put my slide back up with the information for not only the question resource where you can put your questions in, but then also the information for the webinars that are coming up. So give me a second here, and I will switch slides back to, let's just see here. All right, hold on just a second.
Hey,
Patty, Patty, can you hear me?
I'm on the phone. I can't seem to get access to Zoom, but I don't mind. I have the PowerPoint on here, so if I can go on if you want to put the PowerPoint. I'll just let you know when to go on to the next slide.
All right.
Is that all right?
That is fine by me. Let me get your slides here loaded up. Actually, I'm going to quick flip the slide up that has the question, or actually the information for the upcoming GIS remote sensing webinars. If anyone wants to quick take a note of the dates for those, and then we'll switch into your slides, Patty, and we'll let you, I'll give you the mic and you can talk about NIF. So just give me about a minute here to leave this slide up for folks to write down any information they might want about the upcoming GIS remote sensing webinars.
Okay, perfect. Just let me know.
Okay. And for our participants today, these 2 webinars, April 9th and April 22nd, registration is required. That's why there are 2, a link for the April 9th and a link for the April 22nd. So you do need to register for those webinars if you'd like to attend, unlike today. Okay, so I'm going to go ahead and get out of this slide, and let me get Patty's slides up here, so just give me a moment. Okay, Patty, your title slide is up and being shared, so the floor is yours.
Thank you. Hi, everyone. Sorry for the technical difficulties. Seems to be a challenge now that we're all working remotely. But my name is Patricia Sanchez. I'm the NASA Internship Program Coordinator for the NIF program. This is my presentation about what the internship program is and the eligibility requirements, as well as the application process. And please let me know if you guys have any questions towards the end. So next slide, please. And
yep. And you're on the next next slide. Yep, description.
Perfect. Okay. So NASA internships are opportunities for students to get hands-on experience in research and operations in support of the NASA mission. So the internship opportunity allows interns to work alongside career professionals on mentor-directed tasks that contribute to the operations of the NASA facility or the advancement of the NASA missions. So pretty much, you know, this is an opportunity for students to just really get hands-on experience working on a project with a mentor, which is the career professional at the NASA facility across all 10 centers. Yeah, so next slide, Ann.
Okay.
All right. Okay, now I'm in Zoom. Sorry, this is a little bizarre. My computer is just acting a little wonky today. Sorry.
That's okay. We had to have some technology snafu. It's okay.
Okay. Just give me a quick second. All right. So eligibility. So to apply for a NASA internship through the NIF program, you need to be a U.S. citizenship. You need to be a U.S. citizen. If you're a naturalized citizen, you're going to need to provide your naturalized certification. You need to be enrolled in full-time in a degree granting program at an accredited college or university. We also have high school students apply. We do have some, although they are very limited, high school internships over the summer. The minimum is a 3.0 GPA on a 4.0 scale, and you need to be at least 16 years old to apply. Okay, next slide. All right, so NASA internship provides a stipend based upon the academic level of the student at the time of the internship application. So what that means is if you are, let's say, graduating high school and you apply for a summer internship, but you are going to start, obviously, as a freshman during the fall session, you are still considered a high school student and will be paid at the high school rate for the summer. So the same applies for undergraduate and graduate. They are all different. They're depending on the session. So we have 3 sessions annually. The spring and the fall are 16 weeks long. The spring usually is from January to May, and the fall is usually from August, end of August, to the beginning of December. And the summer is a 10-week session, and there are 2 different start dates. Usually there's one from May to the end of July, and then the second session is from June to early August. Those are the 3 sessions that we typically have. So it's fall, spring, and summer. The stipends are usually paid during the first week of the internship, and then it's the biggest, which is 40% usually is the first week, and 40% at the midpoint, and then you get the remaining 20% towards the end of the internship. Internships are performed on site at the designated NASA center. So as you know, during this crazy time that we're all experiencing, we've had to push for remote internships, and that's something that is now becoming a little bit more seen throughout NASA internships through NIF. There are a lot more remote possibilities. However, still the majority of the internships are still on center. The internship is usually a full-time opportunity for all 3 sessions, and that requires the student to work 40-hour work weeks. 40 hours for the work week. So this leads us to the last bullet, which is the internships program doesn't typically provide housing. So what we do offer our students is we provide, well, at Langley, we provide a guide, and usually most centers will provide some sort of guide, and each center does it a little bit differently. But at Langley, we offer a guide that has different options, from corporate housing to extended stay hotels to a long list of renters from the area. Usually they're either contractors or civil servants who work at NASA, who rent out either a room, a house, an apartment, condominium. It's a long list of different options. Okay, next slide. Okay, so how to apply. So to apply for a NASA internship through the NIF program, you would need to visit intern.nasa.gov and create an intern profile and apply for internship opportunities. So you're applying for different projects. I believe you're allowed to apply up to 15 projects. However, once you apply for a project in the system, you're in the database. So all 10 centers can pull your information and pull your application for different projects at their centers that you qualify for. So just because you don't necessarily apply for a project doesn't mean you might not be selected for it if you have the qualifications. So that's something to keep in mind. So you also need the most current copy of your school transcript that shows the cumulative GPA, and at least one person who's willing to write a letter of recommendation. The application system will send the recommender a link to send the letter of recommendation online. You can make sure that the application is complete by making sure that you have all the green check marks on the My Application checklist. So once you've uploaded your transcript and the letter of recommendation is emailed, be sure to hit save at the bottom of each page to certify any changes and hit submit for the application to become active in the system. So this is really important. You need to make sure that if you make any changes, if you go back and make any changes to your application, you need to always hit submit for it to be active in the system. Otherwise, we won't be able to find you. Next slide. So this is a screenshot of the internship application splash page. This is what you'll see as soon as you type in intern.nasa.gov. So at the top is a ribbon with all the important deadlines for the internship program. So right now, the deadline for summer has already passed, but you can go in now and apply for the fall session and even the spring session of next year of 2021. So as there may not be that many projects posted right now, there still are a couple that you can certainly apply to. As we get closer to the session, there will be more and more projects that you may want to apply for. So there's very important information to help you in the application process. So there's a specific video on the website that you can watch from a former NASA intern on their experience. And in addition, you can scan the barcode to find out more information on NASA and the different things that they're doing with the Artemis program. So you can also learn about the Pathways program, which is a way to become a NASA civil servant on the website as well. So it has a lot of information for you. Next slide. Okay. So this screenshot is a view of how the page to create an application or sign into the applicant's account looks. The deadline for each session is also listed here as well. Under the login tab to the left is a link to preview opportunities posted across all of the NASA centers. So I don't know if you can see that. But yeah, so the opportunities can be filtered by session and by center. So please keep in mind that new opportunities are added on a regular basis. So like I mentioned earlier, you can apply for the fall and for the spring already, but there may not be as many projects yet. But as we get closer, you'll probably start seeing a lot more of them. So if you don't see an opportunity that you're interested in right now, I would definitely recommend you continue to check back. So in addition, under the login button is a link that shows things needed to create an application. So that's also really helpful before beginning your application to take a look at. Next slide. All right, so some application tips. I strongly recommend listing every single computer, technical, and other skills in the keyword spaces. So when you're applying on the actual website, you're gonna see like a text box area where you can fill in all that information, and then under that, you're gonna see keywords. I strongly recommend you make sure you put every single skill you have in the keyword spaces. So it might seem a bit tedious because you have to go one by one, you know, submit each skill one by one. But I recommend you do that because we have thousands and thousands of applicants. So the way that some of our mentors look through applications is through the keywords, which is why it's so important, because those are the first things that pop up when looking at different applicants. So if you have skills like Microsoft Office Suite or MATLAB or Creo skills, I definitely think you should. I strongly emphasize you should put them in the keyword space, because that is how mentors will be able to look at your skills when they're looking at hundreds of applicants who apply for their projects. So it's really important. We always emphasize that. So I would even include self-taught skills. So if you taught yourself how to code different, a programming language, I recommend you put that on there, as well as hobbies. Sometimes there are hobbies that really make a student stand out. For example, I know a computer science student who listed photography as one of her hobbies, and it turns out that her mentor was also a photographer, and that was the connection that they had together. So I would include hobbies. Sometimes that stands out in your application as well. I'm just gonna drink a bit of water. Okay, so definitely complete the why you want to be an ARSET intern text field. There's going to be that question in your application, and I know a lot of mentors who read that and who really pay attention to reasons why it means so much to you to want to work at NASA. So I strongly recommend that you take the time to really answer that question in a thoughtful but well thought out summary of why you want to be an ARSET intern. So mentors like to read this paragraph to just get an idea of who you are and why you want to be an ARSET intern. So you should list any past experience in NASA's programs or space grant programs. So past participation in these programs does not guarantee an internship, but it will let the mentors know that you have NASA experience, which is always a nice plus to have on your application. So if you've done any NASA programs like NCAS or, I don't know, I'm trying to think, or space grant programs, definitely make sure that you put that on there. So please note that you don't need past NASA experience. It's not required to get an internship. It's just a nice plus to have on your application, especially if you've done it. So we encourage that you don't wait until the deadline to apply for opportunities. So a lot of the time we have a lot of interns who wait until the deadline. So for example, the summer deadline was March 8th. And that was the last day to apply for a summer internship. We don't recommend you wait until March 7th to submit the application. Apply as early as possible because mentors are selecting as early as they can. So they start selecting for summer in November and even December, all the way up to, I would say even up to March. By March, there will be some projects who will be selecting, but it's not as many. So if you want the best chance to get a NASA internship, I would recommend applying as early as possible. Keep in mind that if you do apply early, you're going to need to make sure that your transcript is updated, because this helps the selections committee to determine your eligibility. Yeah, so an updated transcript is required, but a resume is not a requirement. So just so you were aware. Okay, next slide. All right, so how will I know if you've received an offer? So the first step is you'll be contacted for an interview by the project mentor or the center's program coordinator when you're being considered for an opportunity. So at the time of the interview, you should ask how long before the final decision will be made. Even if you're not selected for the opportunity, it would be productive to ask the mentor why. So based upon the feedback, you can make adjustments to become more skilled in a given area. So even if you may not get that opportunity, it at least gives you an idea of things that maybe you would want to work on, so that maybe you get the opportunity again, either the next session or the session after that. So once you selected for an opportunity, the offer letter will show in your account profile under View My Offers. So you have the option to accept or decline the offer. Typically, you get 5 business days to accept the offer before it expires. So once you have an offer letter pending acceptance in the system, or you have accepted an offer letter, you won't receive additional offer letters for that particular session. Okay, next slide. And last, this is just my contact information, so feel free to email me with any questions that you have, if you have any specifically about the NIF program or just the application process or anything of that nature. Yeah. And then last is the NASA internship application management website for you guys to take a look at. Okay, so that's pretty much it. I don't know if you want to leave it there for a little bit.
Yes,
So
Patty, I'm
right
gonna leave this slide up so that folks can get your email address, but also the website for the intern program if they are interested in either applying themselves or passing that on to their students. I'm gonna leave that up for a moment.
Perfect. Thanks, Anne.
You're welcome. Okay. So we are running a little bit ahead of schedule, so we're going to have some more time for questions here in a moment. So if you have any questions for any of our panelists, please make sure that you go to the web link that should be in the chat box, and I'll put up on the screen in just a moment so that you can get your questions in, and we'll start that in a few minutes. I want to take this opportunity to thank all of the panelists, to thank Chris and Cindy and Rusty and Desiree and Patty for taking time out of their schedules to join this particular program. The original intent or the original plan for this program was much different than what it has actually turned out to be. And all of the panelists have been super flexible and very understanding and patient as we've gone through several different iterations in putting this program together. So for myself, I want to say thank you to all of the panelists for your flexibility and your passion in sharing this information about how NASA uses GIS and remote sensing technologies. So with that, I'm going to quick get out of Patty's slides and then go ahead and put that other slide back up and my slides so that you can make a note of those webinars again. Okay, and give you folks a little bit of time a minute or two to put in those questions in the tool, and then we'll start the Q&A the session here in a moment or so. But there is the web address for submitting your questions. Also, take a look at questions that have been submitted and upvote the ones that you really want me to ask the panelists while we're still on the air. And then obviously there are the websites for the registration links, I should say, for the April 9th and April 22nd webinar. So I'll just leave that up another minute or so, and then we will switch and move into the Q&A session. And Dr. Stout had mentioned this at the beginning of the program. The program has been recording all of this time, and will continue to record through the Q&A. So particularly for professors who may be online, or teachers, informal educators, if you're looking to have this to share with your students, there will be a link to the recording. It won't be ready right away, but it will be distributed as soon as it's ready. So yes, the program has been recorded at this time and will be available for viewing again. All right, so if I'll go ahead and get out of this screen share and just make sure that my panelists are ready to take questions here. Let me switch gears and get out of one and get into the question tool so I can actually see questions. And when you have multiple screens open, it does take a moment or two to actually switch. All right. Okay, so I've got several questions here, and all of them have gotten equal love. So what I will do is I will read out the question, and then I will simply step out of the way and let our panelists jump in and talk whatever they'd like to add to the answer to the question. At this point, the questions that are here are not necessarily specific to a particular panelist. So we'll have opportunity for each one of our panelists to weigh in on the question. So the first question that I have here is, how much human geography is used at NASA? And I will tell you that there's no other information associated with that question. So if the individual who asked that question might want to type in the chat room a little bit additional information, but our first question that we're getting in the chat or in the tool is, how much human geography is used at NASA? So I will step away and let our panelists jump in here.
Well, I can jump in quickly and say that we actually have an entire data center. It's called the Socioeconomic Data Center that has a wide variety of socioeconomic data that they archive and distribute. So that's one way NASA is using human geography. And we often, you'll find pairing of scientific data and socioeconomic data because it's just so interesting. People want to find out, where am I? Why does this matter? And where is the me in this data? And so that's one thing I wanted to mention.
Okay, thank you, Desiree. I think I would like to make sure, particularly for Rusty and Cindy, who did talk about some of the education tools that you can use with GIS and remote sensing. I was wondering if any of the particular tools that were presented address human geography. Rusty or Cindy?
Sure, I can just take on that a little bit. Of course, when NASA scientists are examining environmental data sets to predict and create risk models of vector-borne disease, These are not usually done in isolation. They usually utilize human geography data sets. These are very often local, depending on the scale of their study, but they do use different kinds of data sets. And of course, I think it's really important to mention the socioeconomic data that's comes out of Columbia University. That's also a huge area where you can actually download data and use data that has been archived by NASA. So yeah, it's super important. And if anybody who's worked in the applied science area of NASA knows that that is really, the human, making those human connections is really what that particular area of science is all about. And so you can't do it without examining those data sets. Hope that's helpful.
Yes, thank you. Cindy, did you want to add anything?
Yeah, since I come out of the applied sciences program, Rusty's absolutely right. That's what our program is all about. It's bringing the humans in, and the impact of all of these different things on human beings. And I can give some specific examples, and you can find some of this stuff in the ARSET training programs. But one is looking at disaster risk. So the risk of various vulnerable populations to disasters. That's one of the areas that the Applied Sciences program looks at. And the second one that I'm probably most connected with is something called ecosystem services. So it's basically the benefit that ecosystems provide to human beings. And in order to assess that, you need to know where the humans are, for one thing, and what they're doing, so human activity. So we bring in socioeconomic data along with the environmental data together to look at the impacts that humans are having on the environment, but also the impacts that the environment is having on humans. So those are two sort of solid examples of how we use human geography combined with physical data derived from the satellites that we have.
Okay. Thank you, Cindy. And certainly not to leave you out, Chris, but was wondering if any of the projects that you have had a chance to work on or anything that you've come in contact with when you're at NASA that involves human geography. Did you want to jump in and add anything to the answer here for this question, Chris?
I can really briefly.
Okay.
Excuse me. Really, the kind of the point of us having a local managed GIS service for the center ends up being mission allocation, and that is very much so of human effect, and there is an economic benefit, but it's not nearly on the global scale. In fact, we're kind of like the smallest possible microcosm of an application of GIS in sort of the normal sense of using GIS. So yeah, but really when you look at our main aspects of how we deploy GIS in institutional management, it is pretty much all human. But outside of the center, there's only a basis of the center's aggregated economic impact on the rest of the community.
Okay. Great, thank you, Chris, and thank you everyone for your answers to that. We'll go ahead and we'll move on to the next question, which is actually very timely, considering the fact that we are online in this particular format because of COVID-19. And the question is NASA using GIS to address concerns with COVID-19 or the novel coronavirus? And so I'm not sure if any of you are working directly with that, or if you're able to speak just sort of generally in terms of what you do, how that might tie in with what we're experiencing right now with COVID-19. Okay.
I'll jump in there quickly.
Okay.
One of the things that's come out of Applied Sciences program under our health and air quality program are images, and some of you may have seen these images of the changing air quality, especially in China, due to the restricted, to restricted travel and mobility in general, and how that's affected air quality. So while we haven't yet, I think that's going to change, focus on the virus itself, which is hard, as you can imagine, with satellite imagery or even on the ground imagery. And Rusty can talk about vector-borne diseases, because with vectors you have a direct connection with the landscape or the environment. With something like COVID-19, it's much more challenging to be able to detect the spread of that disease, unless you're connecting it with some environmental condition like temperature or precipitation or something like that. So I think we're going to see more. NASA is going to contribute to looking at how the virus is spreading and things like that. But right now, the most immediate thing I know that's come out of NASA is the changing air quality conditions, particularly in China.
Thank
Yes.
you. Thank you, Cindy. Go ahead, Rusty.
Yeah, Cindy, I think that it has been, for me, one of the most remarkable things to track in the last couple of weeks is what we're seeing with the satellites with respect to air quality. And, it's been really quite amazing, because you really do see the impact of people's activity on the planet. With respect to the COVID-19 problem issue, one of the things that we're doing with Globe Observer actually is we're pulling back. And our message has always been, go outside, make an observation. And we feel as a team that this is not a responsible message. And so we're now saying, yeah, please stay home and look at some NASA resources. And so while we are not directly involved in this research, I think that everybody can understand that the NASA assets that we have available and the tools and the technology that we have available is certainly contributing to the efforts of the broader public health community. But in terms of what we're doing with the Globe Observer and vector analysis, we're saying right now this is not the time to participate. Please do yourself, your sheltering in place, and let's just get through this.
So important thing to keep in mind. Do you have any sort of general comments from your working with the mosquito vector disease in sort of helping kind of understand, okay, so is there anything we can learn from what work has been done with the mosquitoes and the vectors, and have anything in there that might apply to helpfully understanding what's going on here, or there really no connection?
The biggest connection is that mosquitoes are vectors and now humans are vectors. And so you can, that is a really challenging and difficult thing. But beyond that, I think right now, I think that I don't want to complicate things by trying to make any broad assertions. But, seeing people as vectors is a phenomenal change that we really have not seen at the scale ever in my lifetime. So I'm just going to leave it at that. Thanks.
Okay. Great. Thanks, Rusty. I'd like to give Desiree or Chris a chance to hop in here if they know anything or want to add anything to what Cindy and Rusty have said.
Cindy and Rusty said it all really well. I just want to jump in and add that events like these, they make for amazing educational opportunities. So it's these recent events that happen around the world that really drive, their topics of interest. And there's always an opportunity there. As they mentioned, air quality is going to be a big thing that comes out of this. And so we can take that and connect the human dimension to the different, spheres of the Earth system and how this is going to affect the environment. And so I look forward to seeing the results of that.
Chris, did you want to add anything? Well, I saw Chris unmute his microphone, but
Oh, sorry,
there
I
you go.
have a double mute.
Okay.
So what I was going to say is the experts said it all. I really value you guys' opinion and your authority on the subject. And really from the institutional perspective, it's going to change how we work. But I mean, it doesn't necessarily affect the kind of GIS we're doing. I'm still putting out data products, but I just don't have access to my subject material. That's all.
And a related question that I'm not sure that any of us can answer, but we'll go ahead and take a stab at it because it is it's one of those ones that's gotten the most votes. It says, how long can we expect to be closed? So I'm not exactly certain whether or not we can really give a definitive answer. But if any of the panelists would like to answer that question in the context of GIS and remote sensing, I will open up. That was a question that got a lot of votes, so I'll put that out there. And yeah, that's a hard one. You know, we're talking about vectors and humans as being vectors, and I think the safest thing to say is to keep referring to the federal guidelines from the CDC, the updates that we're getting from both our state governors and also from the federal government. Just as sort of an aside, I'm originally trained as a biologist, and so I mean this is as we keep hearing, this is a marathon. This is not a sprint. So that's the only thing that I can say. Please refer to federal CDC guidelines in your states for guidelines on how long this is going to go. But from a personal standpoint, I will simply say this is a marathon. It's not a sprint. All right, and then we have another question here. This one's for Patty, if she is still on the line. We have this question here. It says, how does homeschooling affect getting a NASA internship? So Patty, are you still on the line?
Yep, I'm here.
Okay.
So that is an interesting question. So if you were homeschooled like through high school and now you're in college in a degree seeking program, it shouldn't affect you at all. If you're a college student applying for a NASA internship, but if you are a high school student that is currently being homeschooled, that is, we would need a transcript, and we definitely need a transcript of that shows a 3.0 out of a 4.0 GPA, and I'm not 100% sure how transcripts for homeschool students look like. That's something I can certainly find out, and if you want to reach out to me directly, I know my contact information is listed there. I can certainly find that information out for you. But like I said, if you were homeschooled in high school and you're currently in college, or you're a graduate student and you're applying for a NASA internship, it shouldn't affect you at all.
Okay, and before I see Rusty, it looks like she wants to jump in. Before I turn the mic over to Rusty, if all of my panelists could please type their email address in the chat box. I cannot switch over to the various slides with the email addresses. So if all of you could please type your email address in there, so that if our attendees do have questions specific to an individual, like the individual who has the homeschool question, can actually email Patty. If you could please put your emails in there, that way our attendees will be able to direct their emails and questions to the appropriate person for follow-up. So Rusty, mic is yours if you'd like to jump in on the homeschool issue.
Yeah, I just wanted to say that, last summer we had several high school interns that work with us with the Mosquito Habitat Mapper program. We did a virtual internship, and we did have a couple homeschool students that were exemplary. And so I don't think that there is anything working against a homeschool student. I think homeschool students that apply to these programs, you can find out from your homeschooling association the way to present your package. But we did have several students who applied and were accepted last summer. So just wanted to give you that encouragement. I've had really good exemplary success with some of the homeschool students I've worked with.
Yes, and I would say we had, I believe she was homeschooled. We had a intern. She was a rising junior a couple of summers ago, and you could not distinguish her from the college students or the students who had been in the regular school pathway. Did anybody else want to jump in on that question? Okay. All right, we have actually asked all the questions that were in the question tool. So for the individuals who are still on the call, we have several guests. If you have a question, please feel free to go to the question tool to type in a question while we have our panelists on camera. I will go ahead, and while I'm waiting to see if there's any more questions, once again, sort of give a plug for thank you the work that's been done to put this into fruition. I am actually a NASA contractor and work through Texas State University. Richard Carney has added to the chat box quite frequently, been very regular with the link to the question tool. So he and I are from Texas State University, so I do need to give a big thank you and shout out to Texas State University, who has helped with the technology piece of this in terms of getting the Zoom room put together. And also I want to say thank you to Richard and Keith Duclos, who were kind of in the back, behind the wings, kind of help making sure this ran smoothly in terms of the technology. So I want to make sure that I acknowledge Texas State and Richard and Keith in particular for all their help to make this a successful program today. All right, I'm not seeing any other questions. So what I like to do is give each of our panelists just a couple minutes each to kind of wrap up remarks, and we'll end with you, Wendy. So I'll let all of the panelists go first, and then we'll close with you, Wendy. So let's just kind of go down the list. Chris, did you have any last remarks, about a minute or two to leave with our audience before we go off the air? So Chris, I'll let you go first.
Sure, thank you. Really, I guess my parting message here is, if anyone has learned anything, it's that remote sensing comes in a lot of different shapes and sizes. Sometimes it's satellites, sometimes it's off the back of a truck, sometimes it's a tripod, sometimes it's aerial overflights. There's lots of different types of data sets, even crowdsourced data. All of these types of data have a lot of intrinsic value, and it's really our knack for being able to synergize and be able to bring together all these different data types to give ourselves the largest set of data to analyze, and that will give us the most important, most explanatory power that we can get out of these products. So thank you to the panel. I really enjoy hearing about what other people in my field are doing outside of my little corner of the universe. And yeah, I hope to do this again sometime. Thank you.
Thank you, Chris. Cindy, I'll let you have a minute or two to have any closing thoughts you'd like to share with our attendees.
Great, thanks, Anne. Yeah, I just want to reinforce my message before that, you know, the purpose of our program, the capacity building program, is to make these tools and data more accessible to everyone, and to really try to understand what the needs are out there for these data. So the more we hear from you about how you use the data, the technology, the tools, you know, any of these things, it helps us provide better resources for you. So there's a nice little feedback loop there, I guess. So Thank you for, for listening, and thanks to the panel. There's been some great information across the board, from internships to the actual science that we do. And again, I know on behalf of all of us, we really do enjoy talking to students in particular. But anyway, we can also help out teachers and anyone else out there who's interested in what we do. Please feel free to contact us, and me in particular, anytime. Thank you.
Okay, thank you, Cindy. Rusty, mic is yours.
It's going to get harder and harder for each of us, because I think that Chris and Cindy have already said everything I wanted to say. I got very excited. One of the things that NASA does so well is, we are like I said, an ecosystem that is related to technology and understanding all we can about Earth and space. And I was so excited to hear Chris's talk, because he's really looking at, some of these really cutting edge new technologies, looking at point cloud data. And I think that another thing that NASA has done very, very well is taken its responsibility to get the technologies, get the education about how to use these technologies. It's taken it very seriously. And I think there's a lot of incredible resources that I never even knew about when I was a faculty member at the University of Nebraska. And I've just learned more and more. And today I learned about even more. So I think that, taking an opportunity to sort of explore the websites and to see what's there, and to find the place where you see something resonating with what you're interested in doing in life, and be sure to reach out, because I think that everybody who's working, on our teams is very interested in, forging collaborations and making relationships with new scientists. I think that's all I want to say. But thanks again for the opportunity today to meet all of you, at least remotely.
Thank you, Rusty. Appreciate it. Desiree, the mic is yours for any closing thoughts you'd like to share with our participants.
Yeah, all three of you said it really well. There's a lot of data that is available to us, and sometimes it can be a little overwhelming trying to navigate, all of these different resources. But there is good stuff out there, and we're always welcome to help out in any way we can. There's basically just if you're having trouble accessing data, feel free to reach out. And especially on the MindASSET data side, we're always looking to create virtual connections and provide you with tutorials on our Earth System Data Explorer. So thank you.
Hey, thank you, Desiree. Patty, did you have any final thoughts about the NIST program that you'd like to leave with us today?
Sure. I really hope that those that are participating today really are inspired by the work that these guys do, and that it inspires you to apply for an internship here at NASA. We would love to have you, and we hope that you guys apply for well, currently not the summer, but for the fall or the spring, and even next summer. There's a lot of different opportunities available, so we look forward to having you. Just apply. And if you have any questions, feel free to reach out.
Thanks, Patty. And for those of you who are attending webinars, yes, we do have internships in GIS and remote sensing, as was mentioned, some of the programs by Cindy, Rusty, and of course, Desiree is a former NIFS intern. So certainly if you have that interest in GIS and remote sensing and you're interested in that internship opportunity, please make sure you check out intern.nasa.gov. And with that, I will turn it over to Dr. Stout for any final closing thoughts you may have.
Thank you so much, Dr. Wise. I appreciate it. And I thank all of the panelists so much for the inspiring presentations. I learned so much, and I know that all of the participants who are watching learned as much as I did today. I really encourage everybody to reach out to our subject matter experts as they provided their email addresses, and also to check out all the wonderful links and resources that they have provided for us to learn about, and to incorporate those in our classrooms and our lectures if you're a professor. So thank you again to our panelists, our guests. Thank you again to Dr. Wise and her team for putting this on and working so hard to get this to come together. And I thank you so much for everybody that attended today. Stay healthy, stay safe, and thank you so much.
All right. Thanks, Dr. Stout. And to just kind of wrap this up, I have kind of stayed in the wings all program long and wanted to just make sure that the spotlight was on our presenters. And I just want to make sure that if you have any questions for me, we will make sure to get the recording link distributed to the various outlets as soon as possible. If you have any questions specifically for me, I'm in the Office of STEM Engagement, and I've put my email in the chat box. So if you have any questions for me specifically, by all means, feel free to email me at that email address. But to just wrap it up again, we really appreciate the presenters' enthusiasm and passion. We appreciate their flexibility. These were not the circumstances that I was expecting to be working with when March 23rd came rolling around. But thanks to my presenters and my support staff at Texas State University, we have managed to pull this off. So thank you very much. And as Dr. Stout said, please be safe, stay safe out there, and we will get this recording to you as soon as we can. Thank you so much. Have a great day.